Imagine a galaxy and its light took 25,000 years to get to us. How far away is that galaxy?
25,000 light years away.
Beautiful.
Okay.
Now imagine a galaxy that it took the light 13.4 billion years for the light to get to us. How far away do you think that galaxy is?
I would imagine it's 13.4 billion light years away.
The answer is actually 32 billion light years.
How does that work? Wait.
Yes.
I got the first one right.
There's a galaxy that we actually discovered in 2016. It's called GNZ11. It took about 13.4 billion years for that light to get to us. But the galaxy right now is 32 billion light years away. How is that possible?
I don't know. My brain's already broken.
The universe was just like this stagnant thing. You know, like all these rocks are where they are, and light is emitted from that rock all the way over to this rock. If nothing moved and it took 13.4 billion years for the light to get across from one to the other, then they would be 13.4 billion light years apart. But imagine the space between all the rocks and dirt. Imagine that's all expanding with the rocks. So as light's traveling across, the distance between the rocks is getting bigger and bigger. So even though it only took 13.4 billion years for the light to get from GNZ11 to us, we are now 32 billion light years away from that galaxy. The universe expanded in that time. Yeah, I think this is one of the most unintuitive things about the universe. Space itself can expand. When I first learned that the universe is 13.8 billion years old, so the edge of it should be 13.8 billion light years away. That's how they always talk about distance when they talk about light years, but it's not. It's 46.5 billion light years away. I have to call myself out here because when I talk about the size of the universe, what I meant was the size of the observable universe, which is the sphere of stuff that we have been able to see so far because light has had enough time to get to us. Our observable universe is growing. We don't know how big the universe is. We don't even know if it has size. Anyway, the observable universe is a lot bigger than I thought. I was so confused. How is it possible for the universe to be so much bigger than light has had time to get to us? That concept to me is so confusing and mind-bending, but it comes because all of space is expanding and stretching in the entire universe. Space is not this stagnant thing. It's not like this field of rocks. All of the space-time is spreading apart. There's more and more space being created, and the effect of that is that space is expanding with galaxies and carrying them apart from each other. You start to notice that galaxies are actually receding away from us. So the further away they are, the faster they're moving away from us. Something that's a megaparsec away from us is moving at 70 kilometers per second away. Something that's twice that, so 2 megaparsecs, is moving at 140 kilometers. You can keep going eventually until you get to 299,000 kilometers per second. Do you know what that speed is?
Is it the speed of light?
Yes, yeah, it's the speed of light. So eventually you get to that speed and you plug it into your equation and you get that the distance away from us to a galaxy that's moving away from us at the speed of light is about 14 billion light years away. And that is far within the boundary of the edge of our universe. Here's us, we're, where we are at the center of our observable universe. And then if you go in all directions out 14 billion light years, you get a sphere. And that sphere is called the Hubble sphere, beyond which everything is moving away from us faster than the speed of light. And it's not a little bit of stuff. It is 97% of all galaxies in the universe are moving away from us faster than the speed of light. It's not just a couple.
It's crazy. I'm just trying to process it, honestly.
Here's a question. Do you think that we can see things that are moving away from us faster than the speed of light?
Well, now that you said it, it doesn't sound like we could or will ever be able to, right? Yeah, how is it possible that something is moving faster than the speed of light if the speed of light is the fastest thing in the universe?
The fastest thing, like the ultimate speed limit, the universal speed limit. Yeah. What you're referencing is Einstein's special theory of relativity, which says that nothing can move through the universe, through space, faster than the speed of light. And that's true. But space itself can expand, and the space between two objects can expand such that it moves those objects apart faster than the speed of light. So nothing is actually violating special relativity. Nothing is moving through space faster than the speed of light. Here's a question. Do you think that we can see things that are moving away from us faster than the speed of light?
Well, now that you said it, it doesn't sound like we could or will ever be able to, right? If something moves faster than the speed of light, we will never see it via light.
It's a good guess. I mean, that's like what you would intuitively think, yes.
We'll never see that galaxy as it is. We'll only see it for how it was when the light left it.
So what you're saying is like, you can imagine getting light from a distant galaxy, that the light was emitted like far in the past when things were a lot closer together. Yeah. And then now we're seeing that light, but we will never see those galaxies as they are now. Okay. You are right and wrong.
Cool. glad I came.
Okay, that galaxy we talked about at the beginning, GNZ 11, that galaxy is about 31.96 billion light years away from us now. So that galaxy is moving away from us like 3 times the speed of light or something like that. But you're right, we're seeing it as it was 13.4 billion years ago. Now, it might not even be there anymore. Like all the stars might have burned out. It might have been swallowed by another galaxy. It's crazy to think that there's a galaxy we're seeing that might not even be in existence anymore. No, that's crazy. So you're right. There are some galaxies that are, space is expanding them away from us fast enough that we will never see them as they are now. But there are some galaxies that are outside of our Hubble sphere, so meaning that they're moving away from us faster than the speed of light, but we will be able to see them as they are now. So they're emitting light now, and it will get to us. This is crazy. You look confused. You should be. You're correct. Okay, the galaxy's moving away from us faster than the speed of light. It emits light at us, and initially that light moves away from us, but it's traveling through space until it gets inside of our Hubble sphere, and it's no longer moving away from us. Let me draw it. Here's us, and then here's like shells of distance away from us. So imagine like this is the Hubble sphere. So this galaxy is moving away from us faster than the speed of light because of the expansion of the universe. It emits light toward us, which initially, because the light was emitted from this object going faster than the speed of light, it's going to be moving away from us. So the light's moving away, but it's making its way slowly this way, even though this part is moving away from us. It's making its way slowly, and then eventually it's going to get to distances that are, think about it like this. So remember how I talked about how consecutive distances or distances that are further and further away from us are moving faster and faster? So this right here is, say, moving, 10. This one's moving 20. So as the light goes this way, now it's going into space that's moving less and less fast away from us. Because the expansion rate of the universe, or the Hubble parameter, is slowing down, which means that the stuff that's now at that first circle is not moving away from us as fast as the stuff that was there. Does that make sense? The light does this crazy path where it almost like a boomerang. It's like it goes forward. Ignore this. Light emitted here goes forward away from us and then comes back toward us and eventually gets to us. Does that make sense?
Yeah.
No, it doesn't make sense, but it's so as light gets closer to us, it starts moving faster and faster relative to us. There are galaxies that are outside of what we call the event horizon, the cosmic event horizon. And outside of that, all the galaxies and stars outside of that, we'll never be able to contact them. They'll never be able to send light to us.
And the Hubble sphere, the edge of it is the event horizon.
No, those are actually 2 different things. The Hubble sphere is, inside that, everything's moving less than the speed of light. Event horizon is everything that we can see. There's actually a boundary between those two. Gotcha. It's like a shell between those two, stuff that's moving away from us faster than the speed of light, but the light being emitted from those things now will eventually get to us. That's what's inside that shell. It's like this magical shell. And our Hubble sphere is also expanding. More light is coming inside of our sphere of things that are moving away from us faster than the speed of light because the universe is expanding. But since the universe is expanding, then light can be emitted from a galaxy. Initially, this is so nuts, but the light will move away from us to start and then eventually stop and then start coming toward us relative to us, which seems like that's violating relativity, but it's not, because it's moving through space still at the speed of light because space is expanding.
Do objects get bigger when the universe expands?
Great question. Objects do not get bigger. No, actually. So things can be easily pushed and pulled through space. It's almost like space has no friction. I can easily pull you toward me. I won't, because I like this camera. I'm overcoming, space so easily. Gravity overcomes the expansion of space up until you get to something like 100 million light years. So the local clusters of galaxies are not really affected by the expansion of space. Things are in space, and then space expands and moves and the things go with it. But that's not true if there's something else there to overcome that movement.